28th question. For the given input voltage, 28th question. For the given input voltage, Vin is 10 sin 2 pi t to the functional circuit shown below. The output signal will be. Okay, so we are given a circuit over here and we are given 4 options. We want the output B out. The 4 options are A, this, and then we have B, C and D. Okay, so the correct option here is choice D, which has like a spike here and a spike here, and we'll see why that's the case. So the first thing to do with any such complicated circuits is to divide and conquer. So what you are going to do is first identify parts that perform different functionalities. In this case, I am going to split the circuit here, right over here, because when I do so, I recognize this as what is known as an comparator. And whatever circuit I have over in this side is what is known as a differentiator. Okay, so this is a very simple problem. The key idea or strategy is to identify different functionalities of the circuit. So given an V in here, what will be the V out based on these two functionalities. So what is B in? Let's try to draw what is B in over here. Okay, so we have, this is the time axis, and in the y axis we have a sine curve, right? It's just 10 sine 2 pi t. So when t is 1, we have a full cycle sine curve. This is B in, and the magnitude of this is 10. So this is what we have at this input over here. What happens to the input once it reaches here is the first question that we need to answer. That is very simple. What a comparator does is, it will take the reference value at the inverting terminal. In this case it's grounded, so the reference value is 0 volts. Okay, so the reference value is here, 0 volts. Wherever the signal is higher than the reference value, which is 0, is going to give a saturated voltage. Okay, so in fact, if we were to plot the voltage here, what we will get is, so cycle is, it's 0.5, this is 1 and this is 0.5, okay, and this is time t. Until time is 0.5, we have the voltage to be higher than the reference, which is 0. So till 0.5, here from 0 it rises to the saturation value, stays the same till 0.5. What happens at the after 0.5? Signal is less than the reference signal. Because of that, it will drop and give the negative saturation value and remain so till the signal is lesser than the reference value, which is 0 in this case. So in fact, the option A over here is the output at this point of the circuit, because this circuit is a comparator. Fine. Okay, now we take this signal, feed into this circuit. What does it do? This circuit is nothing but just a differentiator, as I said. So it's going to take in the input signal, plot its slope, okay, over here. Let's also plot that. So we have that time axis and the signal B out over here. This is like B intermediate, right? B in the middle. This is B mid, and the saturation value is like 12 volts. This is minus 12 volts. We notice signal at this point rises from 0 to 12 abruptly. Because of that, there is going to be a slope change here. The only thing we need to keep in mind is that the differentiator also adds a negative sign. So the slope increases, because of that there is going to be a negative spike. Okay, and then in this region the slope remains 0. There is no change in the function, right? It's a constant. Because of that, as soon as the spike rises, or in this case goes down, it will come back to 0 as soon as possible. Will stay at 0 till time is 0.5. Then when it hits 0.5, there is a drastic decrease in value. So there is a decrease in slope, and adding a negative sign to this, there is going to be a positive spike. Okay, there is a positive spike, and then you notice all over here the slope doesn't change, the function remains a constant. So the spike will return to 0 as soon as possible and hit this value till 1. So this is a very simple problem. All we need to understand is what are the different parts in it, what are their functionalities. Okay, let's also take a look at the other options we have. As I said, the option A is essentially the voltage we would get at this point of the circuit. Then option B is what we will get if we had an integrator. Okay, so let's say instead of this capacitor and this resistor, if they were replaced, okay, what we will have is an integrator. In that case, you integrate this function, you will get essentially option B. Okay, and option C is just negative sign wave, doesn't matter, I mean doesn't make sense at all, just a change in sign. And of course option D is where the changes in slope are picked up with a negative sign. So option D is the correct answer. See you with another video. Good luck.